This is one of the rare opportunities in math where I think the applications are going to be easier than the rest of the section. These applications don't use very complicated equations. There's some fun stuff that you can do, but the book stays pretty simple. All right, so shed a little tear and let's look at these problems. As always with applications, feel free, if you want to copy these problems down, you can pause the video and copy them down into your notes, but I don't want to take the time in the video to write down everything here. So we've got a loading ramp. It's placed next to a truck. Ooh, I'm gonna give us a nice. Just made a comment, right? I don't want to take a lot of time, but I'm gonna take some time with this. So we got a truck. We got a loading ramp. Maybe something like this. And the truck is the base of the truck where we're loading, right? This is 4 feet. Ooh, not 5. The height of 4 feet. And the ramp is 15 feet long on the diagonal. Like the actual board, actual platform is 15 feet. So that's that 15 feet right there. It's asking what angle does it make with the ground? Well, we've been doing this since chapter 7. Okay. This is just saying find theta for this triangle. Well, how do we relate these 3 things? We have an angle, its opposite, its hypotenuse. Oh yeah. Sine of theta is 4/15. We can't find this exactly. We don't have to worry about all the weird answers because this is real life, and real life has weird answers, never mind. But in these physical problems, usually we care about angles in the first quadrant. So in this case, it is just going to be the inverse sine of 4/15. Let's write it as degrees. We a lot of times use radians for scientific applications, but for like day-to-day stuff like this, usually degrees. So inverse sine of 4/15. That gives, Desmos always gives you your answer in radians. So radians to change is 180 degrees, is the same as pi radians, about 15.466 degrees. Like so. There we go. That's it. Example 8's a little trickier, but not much. We have a woman who's 1.5 meters tall, and it's looking at the top of a 20-meter building while standing 8 feet away. What angle is her head tilted at? Wait, how much is 1.5 meters? 1.5 meters is about... Oh, wait, that's pretty short. All right, that's fine. Sorry. There's nothing wrong with being... Goodness. I am so judgy today. I'm sorry. I apologize. I just thought 1.5 meters was taller. Anyway, it doesn't matter. Okay, so let's draw a picture. Again, so there's this woman. And she's about 1.5 meters tall. Oh, this figure is not going to be drawn for scale. Here, let's fix it. We need to... Oh, no. There we go. Let's move her down here. I could have maybe just done the drawing again. Okay. So, and then she's looking at the top of a 20-foot building that's 8 meters away. Or 20-meter building. This building is 20 meters tall. She is 8 meters away from the base. The question is, what angle is she looking at? She's looking at the top of the building. Well, so technically we should calculate, well, what's the distance between her eyes and the center of her head? But we're gonna just say that her eyes are 1.5 meters above the ground. All right. So in this triangle, what are the dimensions? Well, this is still 8 meters. This is 18.5 meters, right? 20 meters minus 1.5. We're going to assume her eyes are at the top of her head. Not totally a correct assumption. We're looking for this angle. How do we relate an angle? It's opposite and it's adjacent. Tangent. Okay, so tangent of theta is opposite over adjacent. The theta is going to be the inverse tangent of 18.5 over 8. Inverse tangent 18.5 over 8 is that many radians. Convert it to degrees, 66.6148. On average. Close to 60 degrees. All right, the building's not that far away. It's pretty tall. Yeah, she's gonna look up pretty high. All right, and that's this video. Good luck on these applications. Take a nice, relaxing application. You don't get this often. Usually the applications are the worst, but I think for this section especially, the applications are much easier than the other ones. So congrats. Surprise, a little positive surprise. Usually we only have negative surprises in math, I think, where difficulty is concerned. Let me know if you have questions, though. They're not all easy, right? They're just, I'm not saying they're easy. They're just not as hard as some of the other ones, right? All right, good luck.